Now you are trapped inside a sealed chamber. The only way out is a portal, but it's locked. Inside the chamber, there is a big right triangle, labeled ABC. The side length of triangle ABC is follow a classic ratio, 3:4:5. Now, inside this triangle, there is a straight boundary line. This line divides triangle ABC into two regions, intersecting the sides of the triangle at point D and point E. The length of D is exactly 50 meters. Around the chamber, you see 3 control panels. Each panel requires a 3-digit code. Only when all 3 codes are correct will the portal open, allowing you to escape from here. Nearby, you find a note left behind by someone before you. The note reveals an important clue. On the sides or vertexes of triangle ABC, there exists exactly 3 points. Each of these 3 points can form a right triangle together with D and E, and the right angle lies directly on one of the 3 points. Fortunately, you also discover a smart detector. This device can measure the area of any right triangle formed with the point this device located and line D as hypotenuse. So, you begin exploring along the edges of triangle ABC, and on side AB, you quickly find 2 valid points, F and G. The detector shows the area of triangle FDE is 625 square meters, and the area of triangle GDE is 600 square meters. You enter these values into the control panels, and both are accepted. Now, only one code remains, and you already know where it must come from. The third point is the vertex C itself, and triangle CDE is naturally a right triangle, with the right angle at point C. But there is a problem. When you approach the boundary line D, you discover that the region on the other side is filled with deadly gas. A simple breath of the gas will definitely kill you, which means crossing the boundary and physically measuring the area are impossible. So the final question is this. Can you calculate the last 3-digit code without crossing the boundary line D? Or in other words, can you calculate the area of triangle CDE using only geometry? Please think carefully, and use your advanced brain. Let's now work through the solution step by step. The first thing to notice is that this is, at its core, a geometry problem. So we begin by translating the story into a clean geometric diagram. From the description, we are told that triangles DFE, DGE, and CDE are all right triangles. Moreover, their right angles occur at points F, G, and C, respectively. This observation leads to a crucial insight, that points C, D, E, F, and G all lie on the same circle, with D as the diameter. Now, let's bring in the numerical information. We are given that the length of D is 50 meters. We are also told that the areas of triangles DFE and DG are 625 square meters and 600 square meters. Using the area formula for a triangle, we can compute the heights from points F and G to hypotenuse D. So, for triangle DFE, the height Fx equals 25 meters. For triangle DGE, the height GY equals 24 meters. Here is where an important geometric fact comes into play. In a right triangle, the maximum possible height drawn to the hypotenuse is exactly half the length of the hypotenuse. This happens if and only if the triangle is an isosceles right triangle. Since D equals 50 and Fx equals 25, triangle DFE must be an isosceles right triangle. This immediately tells us two things. First, the angle DF is 45 degrees. Second, the point X, the foot of the height, is also the midpoint of D, and the center of the circle, meaning dx equals Ex equals Fx, equals 25 meters. Now let's examine triangle DG. Here, the height GY is 24 meters. So using the projection theorem, we know that GY square equals to dy times EY. Then we let dy equals y, then EY must be 50 minus y. Substituting the values, we get this equation, and solving this equation gives us two possible solutions, y equals 18 and y equals 32. From the diagram, we can see that point Y lies farther from D than point X, which is at 25 meters. Therefore, dy is greater than dx, which equals to 25 meters, and we must choose dy equals 32 meters and discard the other solution. This allows us to compute the angle EDG, which equals to arctangent 3/4. And because angles EDG and EFG subtend the same arc EG on the circle, they are equal. So we know that angle EFG also equals to arctangent 3/4. Next, recall that triangle ABC is a 3 to 4 to 5 right triangle. This means its acute angle B is also equal to arctangent 3/4. Now let's focus on triangle CDE, which is the one we ultimately care about. Let angle CED equals alpha. From the diagram, angle CEF equals the sum of angle CED and DF, which gives angle CEF equals alpha plus 45 degrees. On the other hand, by the exterior angle theorem applied to triangle BF, we also have angle CEF equals to angle B plus angle EFG, which equals arctangent 3/4 plus another arctangent 3/4. That simplifies to angle CEF equals 2 times arctangent 3/4. Equating the two expressions for angle CEF, we get alpha equals to 2 times arctangent 3/4 minus 45 degrees. To compute the area of triangle CDE, it is helpful to find tangent alpha. Let beta equals arctangent 3/4, then tangent beta equals to 3/4. Using the double angle formula, we get tangent 2 beta equal to 24/7. Now applying the tangent subtraction formula, we have tangent alpha equals tangent 2 beta minus 45 degrees, which is calculated to 17/31. Well, it's time for our final step. Since we get tangent alpha equals 17/31, which express the ratio of two right angle sides of triangle CDE, we can just let CD equals 17x, and CE equals 31x, and we already know that DE equals 50 meters. After applying the Pythagorean theorem, it gives us the x equals to square root of 2. Therefore, CD equals 17 times square root of 2, and CE equals 31 times square root of 2. Finally, we compute the area of triangle CDE, which equals to 1/2 times CD times CE. And the final answer is 527 square meters. This means the final 3-digit password is 527. Once you enter the last password 527 in the third panel, the portal opens, and you finally escape the chamber. If you enjoy puzzles like this, and want more geometry problems that challenge your math skills, please subscribe to Advanced Brain and keep thinking smarter.